Hello everyone! Welcome to this webinar dedicated to deodorant and antiperspirant efficacy testing solutions. Let's wait 1 minute more for all participants to connect. Hello and welcome everyone. Thanks for joining this online session. I'm Charlotte Tournier. I'm product testing expert and head of SenseNet France. I'm very pleased to welcome on this session Fabrice Monti, CEO at Microfactory, our partner for in vitro evaluation of antiperspirant products. Hello Fabrice.
Hello Charlotte.
A few words, Fabrice, to introduce yourself and your company?
Sure. I am the CEO and co-founder of Microfactory, which is a French startup based in Paris. I am an expert in microfluidic domain. Microfluidic is a science which is able to control the fluid in the very narrow channels, and with the microfluidic, it's possible to mimic the most of biological process. 5 years ago in Microfactory, we were able to mimic the sweating process, and we developed SmartPort technology dedicated to the antiperspirant evaluation.
Thank you, Fabrice. Together, we will be hosting this presentation. We are going to give you some highlights regarding antiperspirant and deodorant testing solution. Please feel free to submit your question or comments through the chat feature in the bottom right corner of your screen. We will provide you an answer by email shortly after this webinar. So now, let's start?
Let's start.
Consumers pay more and more attention to scents and to a healthy environment. Often the presence of malodors is perceived as compromised hygiene or even as health threat. The increasing use of highly functional cosmetic products reflects how much consumers care about their health, their appearance, and they also request longer-lasting protection against body odor formation. So, after a short introduction of our companies SenseNet and Microfactory, we are going to explain you how sweat is generated and which odorous molecules are responsible for body odor. We'll then present you different in vitro and in vivo methodologies available to evaluate the efficiency of antiperspirant or deodorant products. SenseNet is part of the OdorNet Group. The OdorNet Group is the largest odor measurement consultancy in the world, with almost 40 years of experience and practical knowledge resulting from thousands of studies in all relevant sectors. The SenseNet brand, created in 2018, is fully dedicated to odor evaluation of product and materials. SenseNet is a global company with offices and laboratories in Europe, India, and Brazil. Thanks to its deep expertise in sensory and molecular analysis, SenseNet helps companies to improve the sensory attributes and substantiate claims on their consumer product and materials, as well as to unravel and understand the molecular origin and composition of odors.
Microfactory is a startup was born in academic lab in one of the best school of engineer, this is the ESPCI in Paris. The main research of this lab is the microfluidics. Microfluidics is a science which is able to manipulate fluids in a small quantity through small channel. This science has been identified by experts as a revolution to mimic biological activity. During the last 20 years, many new applications born every year with high impact. 5 years ago, with two of my colleagues, we decided to start microfactory project. Our idea was to mimic a part of the real skin, the sweating process. As you know, skin includes 10 million of sweat glands and produce every day around 1 liter of sweat. We create the first artificial sweat pore and we call it Smart Pore. Smart Pore is protected by 3 patents and dedicated to the antiperspirant evaluation. In addition of Smart Pore, we made a specific instrument, we call it SOD4, which is able to control fluids at very high precision and control all environmental parameters such as temperature and humidity. Inspired by this innovation, we started a new project to mimic another human fluid, the sebum excretion. And during the last exhibition of Cosmetic 360 in October 2021, we presented U-Skin, which is an evolution of Smart Pore. U-Skin is dedicated to fast makeup evaluation, but this is another story.
Let's start now by talking about the mechanisms of sweat formation and how to fight its apparition and smell. Body odor is very often perceived as a lack of hygiene, and its social impact can be strong as it is considered offensive in many cultures. Since ancient times, people have tried to prevent, reduce, or mask body odor with cosmetic products. Various strategies based on different types of active ingredients have been developed to control body odor. There are 2 main classes of products on the market today: Antiperspirant, which aim to reduce the flow of perspiration, and deodorants, which aim to neutralize or mask the smell of sweat. The market for deodorant and antiperspirant products is growing rapidly. The CAGR is projected to increase by more than 5% by 2027. The global market is then expected to reach about $35 billion according to Research and Markets South. The trend is therefore towards the development of products more and more efficient and functional, offering, for example, an effective and long-lasting protection against body odor formation, effectiveness up to 72 hours or 96 hours, effective in all situations, for example, protection against stress or sport activities. The cosmetic industry is also very interested in the skin microbiota. This term covers all the microbial flora naturally present on the skin's surface. There is a strong market trend to develop natural active ingredients and finished products that respect the skin microbiota. These innovative active ingredients attempt to modify the metabolisms of the skin's microbiota while preserving their viability and diversity. In this context, manufacturers are seeking to understand the mode of action of these new active ingredients and to specifically study their impact on the generation of volatile odorant compounds. This new trend opens the way to new methodology and strategy for testing the efficacy of deodorants. But before discussing these testing strategies, it is important to understand the mechanisms of sweat formation and associated odors. These unpleasant odors are mainly caused by the bacterial breakdown of skin gland secretion by the bacteria naturally present on the skin. They are particularly noticeable in the armpits area and feet. 2 main types of sweat glands are present in the human armpit: eccrine and apocrine glands. These glands are responsible for the secretion of sweat. Sweat is a natural phenomenon that plays a fundamental role in the thermal regulation of the human body. It also responds to emotional stimuli. The eccrine glands are present in large quantities in the armpits. They can secrete up to 3 liters of water per hour. These secretions help to keep the axillary area moist and contribute to the body's thermal regulation. Sweat from the eccrine gland is naturally odorless. It contains mainly water and electrolytes. Apocrine glands secrete a much smaller volume of secretion, a few microliters per day. Their secretions respond to emotional and sexual stimuli. They only become active at puberty under the influence of the hormonal system. These secretions are thicker and milky than those of the eccrine glands. They are also initially odorless and contain lipids and proteins. These compounds are thought to be the main precursors of the smell of sweat. Sweat secretion rich in organic matter serve as an ideal culture medium for the growth of a number of bacterial species. The most abundant types of bacteria on the surface of the axillae are Corynebacterium, Propionic bacterium, Staphylococcus, and Micrococcus. The composition of the axillary microbiota varies considerably from one individual to another and depends on gender, age, genetic factors, etc. Naturally odorless, sweat becomes malodorous under the combined action of oxygen in the air and enzymes produced by the axillary microflora. These enzymes, particularly lipase and protease enzymes, transform the precursors present in odorless sweat secretion into malodorous volatile compounds. Microbial degradation processes in the armpit generate a wide variety of odorous metabolites. Three major families of volatile organic compounds have been identified as being predominantly involved in axillary sweat odor: volatile fatty acids, thioalcohol, and steroids. Many volatile fatty acids are involved in the odor of sweat. These compounds, which are responsible for the pungent, rancid, cheesy, and acidic notes detected in sweat, are thought to be the main contributors to the smell of axillary sweat. Thioalcohol are sulfur alcohol. These compounds have very low theoretical odor threshold. Their presence in very small quantities is therefore sufficient to be detected by the human nose. Two odorous steroid derivatives are also thought to contribute to the smell of sweat: androstenone and androstenol. These two steroids, also present at very low concentration in sweat, could nevertheless contribute to the malodor because of their very low theoretical odor threshold. It should be noted, however, that 50% of the population would be anosmic to these compounds, which means that their odor will not be perceived by half of the population. To limit the generation of sweat and/or associated odors, there are different types of products and modes of action. Antiperspirant products will fight against sweat by putting inorganic salts into action as astringent agents. Some active deodorants act on the bacterial flora to limit its development or on certain enzymes to limit the generation of volatile odorous compounds. Finally, a last category of products is dedicated to the neutralization or reduction of sweat odors by means of absorbents or perfumes. Some products also consist of a combination of two or more of these modes of action. Whatever the product and its mode of action, the performance, efficacy, and longevity of these new products must be validated to meet customer expectations and find a place in this highly competitive market. These efficacy tests are also necessary to support the efficacy claims made on the packaging and thus meet regulatory requirements. We will now introduce you the different testing solutions we can offer to evaluate the efficacy of antiperspirant and deodorant products. The objectives of evaluating antiperspirant and deodorant products can be varied. The need for tests to support claims is well known, but tests can also aim to screening of prototypes or understanding the mode of action of active ingredients. For each antiperspirant or deodorant product and for each evaluation objective, there is a test solution. This solution can be in vitro or in vivo. The in vitro tests are very often innovative solutions, whereas in vivo solutions are well known as standardized and recognized methodologies. We will start by zooming in on in vitro testing solutions. These methods are very relevant at the research and development stage to support the choice of active ingredients. I'm going to give the floor to Fabrice, who is going to present the solution developed by Microfactory to evaluate antiperspirant efficacy of actives, prototypes, or products.
The main idea of SmartPour is to help the cosmetic actor during the R&D process flow. No need to wait for testing on volunteer to evaluate the efficacy of your antiperspirant. Thanks to SmartPour, you can do it at any time. On this slide, you can see the number 1. Number 1 is the microfluidic chip, is a SmartPour. SmartPour is composed of 4 independent channels. There are biomimetic size, the size is fixed at 16 micron. These pores are open on the flat surface, which is mimic the skin, and this surface has exactly the same wettability properties as the human skin. Associated with SmartPour, you can see on the slide the SOD4 instrument. SOD4 is composed with different parts. The number 2, for example, is the climatic chamber. With this chamber, inside this chamber, is possible to regulate with the high precision the temperature and humidity. For example, if you want to reproduce the Brazil condition, it's in your lab, it's possible. The number 3 is a microscope integrated, and this microscope records the evolution of the interaction between the sweat and antiperspirant. With this microscope, through this microscope, it's possible to see in real time the plug formation, and we will see how. Thanks to SmartPour technology, you will observe for the first time what's happening when you apply antiperspirant under your armpits. On this slide, there is a video. This video shows inside of SmartPour during a standard experiment. I start the video. You can see here 4 channels. This is the yellow line, and we apply the antiperspirant on the down part of the SmartPour. And you will see in real time the clot formation. The clot is the interaction between antiperspirant and the sweat protein. During 1 hour, you can see the clot formation due to the active presence of the antiperspirant and the protein of the sweat. After 1 hour, the SOD4 machine increased the pressure to measure the force useful to push the clot out of the channel. With these experiments, we have also different information such as the clot formation time or the length of this clot. And finally, this technology is useful to compare the action of 2 functional assays with each other, or to study the behavior of new active ingredient, such as the film forming of the occluding action. Or it's also possible to compare antiperspirant efficacy of different functional actives.
Thanks a lot, Fabrice, for the presentation of this interesting methodology. For the evaluation of the deodorant efficacy of products with antibacterial or enzyme-inhibiting properties, SenseNet is currently working on the development of a new methodology for the in vitro generation of malodorous compounds from sweat and the evaluation of the efficacy of deodorant formulas and actives. This new method will be based on the in vitro culture of a skin flora representative of the axillary microbiota on a culture medium enriched with precursors present in sweat. The volatile organic compound generated by the degradation of the precursors by the bacteria will be captured using SenseNet expertise in odor sampling. The collected headspace could then be analyzed by sensory and/or molecular analysis. The development of this in vitro method will help companies in the early stages of product development, saving them time and money. It will also provide a better understanding of the mode of action of certain active ingredients and their impact on the metabolisms of bacteria and on the volatile odorant compounds generated. For deodorant products with a mode of action based on sweat odor reduction or absorption properties, SenseNet can also offer in vitro protocols. In this case, the active or formula is directly put into contact with artificial sweat on a support mimicking skin surface. After generation and sampling of the headspace at defined times, the malodor intensity or odor concentration can then be evaluated and compared with a control sample of artificial sweat alone. By the way, if you want to know more about odor sampling and sensory or molecular analysis, don't hesitate to consult our other webinars available on our website. The use of molecular analytical method may also be relevant to report on the impact of a formula or active on the sweat fingerprint. These tests can be conducted using synthetic sweat as well as sweat collected ex vivo from volunteers. The molecules mainly followed will be those presented at the beginning of this webinar. It means volatile fatty acids or sulfur compounds. A comparison with their respective odor threshold will allow to define their potential perception. Let us now turn to in vivo evaluation method. As previously mentioned, these methods are mainly implemented before products are launched on the market, and they are used to support efficacy claims. Let's start by talking about antiperspirant and efficacy testing. A Food and Drug Administration guidelines defines the condition for carrying out this test. A panel of volunteers follows a conditioning protocol in order to prepare the armpits for the study. Then, after a defined number of applications of the product to be tested, we carry out evaluation at time defined according to the claims that our client wishes to make for its product. Generally about 24 hours and or 48 hours. The evaluation is done by putting a pad to collect sweat and is then based on gravimetric measurements. The quantity of sweat secreted over a given period under given condition after application of the formula to be tested on the one end and a placebo on the other is measured. Statistical processing makes it possible to conclude on the efficacy of the active ingredient or the formula. Numerous parameters can be adjusted on this test, such as the profile of the panel, man, woman, age, or even the activity followed by this panel during the test. For example, we can propose standardized conditions with a physical activity such as cycling in our laboratory. For the evaluation of the efficiency of deodorant products, the protocol is like the one presented above. The difference lies in the method of evaluation. We speak here of sniff test since it is a question of evaluating the reduction in the intensity of the smell of sweat in volunteers after application of the formula to be tested. The armpit treated with the test product can be compared to an untreated armpit or to an armpit treated with a placebo, same formula without deodorant active ingredient. The ASTM E120714 standard specifies the condition for carrying out this test. It should be noted that these two protocols for testing antiperspirant and deodorant efficacy can be combined, thus considerably reducing the cost and duration of the studies. Sniff tests requires the use of trained sniffers that evaluate the intensity of the odor of sweat. Our sniffers are so selected according to the requirement of the standard EN 13725 to check their acuity. Their performance is then monitored through training on the intensity scale according to olfactory reference such as butanol or isovaleric acid and blind evaluations. All the in vivo tests presented can be finalized by a consumer test to report on the consumer's experience when using the product. The perception in terms of reduction of sweat odor can be evaluated, as well as any other parameters such as ease of use, appreciation, or comfort. As these are more subjective parameters, this type of test requires a larger number of participants to ensure the robustness of the data collected. In conclusion, we can say that with all these tests, and in particular through this collaboration with Microfactory, we can offer testing solutions for antiperspirant and deodorant products adapted to each stage of product development, from the R&D phase to the selection of the prototype and the substantiation of the claim before market launch. We are now coming to the end of this webinar. Thank you for your time and attention. If you have any question, please don't hesitate to contact us directly by email. You can find all the contact details of SenseNet and Microfactory on the right of this slide. You can also follow our news on LinkedIn. So thank you, Fabrice, for your participation in this session.
Thank you very much, Charlotte, to invite me here. It was a very great pleasure to be here today. And I hope we can work with everybody very, very soon.
Yes, and thank you very much all for your participation. We hope to exchange with you soon. Bye.
Bye-bye.